Okay, suppose this time the force which is being applied on the block that is not acting parallel to the plane of the wedge, it is at some angle alpha with the plane of the wedge. Now this time you have to find what is the minimum amount of force that one should apply in this orientation so that the block starts to move up the plane of the wedge. The wedge is fixed. Okay, so get an expression of minimum force. The expression of minimum force would be mg into mu cos theta plus sin theta upon cos alpha plus mu sin alpha. This is what you should get, and hopefully you must have got. Okay, so let's discuss it now. How you will reach to this expression. FBD, that's where you have to start from every time. Mg is acting downward. Friction force, you're moving it up the plane. So the friction force is going to act down the plane. And normal reaction is perpendicular to the plane. And the external force is at an angle alpha to the plane. Now, if you're looking at the minimum force, then the component of the external force parallel to the plane should be just balancing the opposing forces which are parallel to the plane. So let's break all the forces parallel to the plane and perpendicular to the plane. Now in this case, the force which is going to bring this block upward, going to cause upward motion of the block, is F cos theta alpha. Now this F cos alpha should be able to overcome friction force and should be able to overcome the component of mg which is along the plane, which is mg sin theta. Right? And now you have to get the expression of friction and put it here. That's it. Friction is mu times normal reaction. Normal reaction in the plane perpendicular to the plane of the wedge, if you see, there will be three forces: F sin alpha, mg cos theta. Now normal reaction and F sin alpha are upward, mg cos theta is downward. So normal reaction plus F cos alpha, F sin alpha should be equal to mg cos theta. So normal reaction from there you can get as mg cos theta minus F sin alpha. Now you have to put the expression of friction here and you're going to find out capital F. So going to be pretty simple. I'm leaving it here. From here you can see you are going to get the expression which I have written above. Okay, so I'm not doing it, you will easily get it. Now suppose this time you are not pulling it upward, but the force you are applying is just avoiding the slipping of this block on the wedge. So suppose the block is about to slip and you came to the rescue of the block and you applied some force at the same angle so that the block stopped slipping. So this time, what should be the minimum amount of force to avoid slipping? And as we had a discussion before, to avoid slipping, friction force will be acting upward instead of downward. That's it. And rest of the calculations and everything will remain the same. The expression that you will get, which you should find and not take it for granted, the minimum force, in order to avoid slipping, you would get as mg into sin theta minus mu cos theta upon cos alpha minus mu sin alpha. You should see whether you're getting this or not. You got it? If you got it, then you're very, very good. You're learning friction. Okay, now suppose we have a situation like this. There are two blocks kept on a rough surface tied with a string. Okay, suppose this is a 10 kg block and this is a 20 kg block. Instead of giving you the value of friction, I'm straight away giving you the value of limiting friction. Limiting friction, suppose here between this block and the surface is 60 Newton, and limiting friction, suppose here, is 90 Newton. Now a force of 100 Newton is applied on 20 kg block, and a force, suppose, of 120 Newton is applied on the block of 10 kg like this. Now it is given that the system is a stationary, no block is moving with respect to the ground or with respect to each other. Everything is a stationary. So in that case, you have to find what is the value of friction and what is its direction at each contact.